this section, we're going to take a few minutes and go over statistical notation. Now, it's very important that you keep track of these symbols and what they mean. They are quite literally the language of statistics. So if you're struggling with this, I suggest you take a separate sheet of paper and start writing off to it your notations, the definitions, and add in examples to help you keep track of what we're looking at. Let's go through these one at a time here. First of all, the sum signal simply is the sum of all data set values. So that is what it means whenever you see this notation. It means we are summing everything. Here in this example, if we were looking at the sum for the class pulse rate data, we would literally add every single one of them together, and we would get a sum for the class pulse rate data of 1,363. X is a variable that's used to represent individual data values. So we would use X both to say X represents the class pulse rate data as a variable. Class pulse rate is the variable. We also could use X to represent individual class pulse rate data. So for here, X equals 65, X equals 67, and so forth for each of the data points. So X can both refer to the variable category of pulse rate or the specific data points. Now, the lowercase n indicates the number of data values in a sample. So if we were using this data to make a prediction of the pulse rates of all USF students, we would use a lowercase n, and our n would equal 20. That's how many data points we have. Now, if we were using this data to make a statement of the pulse rate of students in this class that we had measured it from, then we would be using it as a population, and in that case, we would use a capital letter N. Notice that the designation of whether it's a lowercase or an uppercase depends on how the data was collected and what conclusions you intend to draw from it. This is important to keep track of this, and we do use separate notations to indicate them because it would not be uncommon in a study to be using both. So, an example of this would be if I was looking at collecting information regarding fish in a particular pond and I wanted to know how well my sampling technique worked. I might try to do an entire population, for example, at one set as we release the fish into the lake, right? And then do a sample of that to see how well my sample is representative of the larger population. This would help me develop an appropriate sampling technique for the fish in the lake for future studies. So on my clipboard, I would have both a capital letter N for the entire population as we release them, and a lowercase n as we did the sample. As you can see, if I didn't have these designations of a sample and a population built into it, it'd be really easy to get these amounts confused. Now the last thing, two things we're looking at here is the beginning of using some of our statistical formulas. So if X bar is the mean of a set of sample values. So if we're using this data to make a prediction of the pulse rates of all USF students, we would produce an X bar. And here you can see on the right, I've gone through and done the calculation for you. So you literally take your sum of X, that's what that means when you see that symbol, which in our problem here is 1,363, and you're going to divide it by your lowercase n, which is 20, and you get 68.15. Now, take a moment and look at this and look at your text. We've left out an important step. See if you can identify what it is and what we need to do to fix this problem. What we need is our rounding rule. Remember, I told you it's very important to pay attention to your individual rounding rules, and we don't always use the same rounding rule. This is going to change for the different types of calculations you're doing. So you need to make sure you're always including the rounding rule in your notes right below the formula. Here, our rounding rule is that the mean, median, and mid-range, you carry one more decimal point than is present in the original values. This allows you to have a certain degree of exactness without overstating it. For the mode, you leave the value as it is without any rounding, since it is an actual data value. So, let's go back and apply this to our calculations of the mean above, and we can see that what we're going to do applying our rounding rule, we're going to get a mean of 68.2. Here, if we're using this data to make a statement about the class pulse rates of the students in the class, we would use a different symbol. The symbol is called mu. Actually, literally mu, just like cat. So when we're looking at this particular sample set, we can see that we're using basically the same calculation in terms of taking our sum of x and we're dividing it by our capital letter N. So the designation of x bar or mu depends on how the data was collected and what conclusions you intend to draw from it. Just the same as when we looked at for the lowercase n or the capital letter N. So I have an important suggestion for you all to keep these things straight in your brain as you're going through and working on the problems. I suggest that you use different colored pencils or ink to indicate whether what you're working with is from a sample or from a population. This will help you keep track of what symbols you should be using and also the conclusions you can draw. Now, this is where we take a moment and I tell you a story of myself from graduate school to help you understand how important using colors can be and why, if they work for you, you should do them. First of all, human beings are visual learners. So vision we learned from a long time before we started having language or mathematical symbols. So it's very easy to be influenced by the visual representation of data. When I was in graduate school and I was taking my final statistical class, which is multiple linear regression analysis, which is truly an amazingly intense course. When I showed up for class, I had my books, my notes, and I had a set of colored pencils. We were doing formulas for overlapping Venn diagrams, and that meant that each individual little section in that Venn diagram had its own little formula that we needed to remember and keep straight for which one we would use where. This was incredibly confusing for me, and so I took my Venn diagram images, colored in each of the small sections as it needed to be done, and then put the formula for that particular section in the same color. This helped me keep straight which formulas went with which components of my very complex Venn diagram. Now, my professor, who was from Germany, came in, Dr. Luttenschlager, and he came in one day and saw me sitting there with all of my stuff spread out, and he goes, what is this? You have picture pages for statistics, right? And I was like, he's like, is Mr. Rogers going to help you with your statistics? He was not the nicest man. At this point, I was a pretty seasoned graduate student, so I figured out if something works for me, I was going to do it. So I looked him straight in the eyes, and I said, yes, it is picture pages for statistics. Thank you, Dr. Lautenschlager. So for the next couple of weeks, whenever Dr. Lautenschlager was doing problems up at the top of the board, he would ask me periodically, Miss Adams, what color should we make this formula? Shall we make it purple or shall we make it green? So this is not, by the way, appropriate professional behavior. We do not target and mock our students. However, Dr. Lautenschlager, as it may be, in graduate school, perhaps you can get away with more. Anyhow, on with the story. So after going through this for several weeks, I continued to use my colored pencils because that was what I needed to understand what I was doing. So we have our first big exam. Dr. Lautenschlager comes back into class with the exams and tells us all that he is filing for a new department grant to give us all colored pencils because I was one of the only 2 people in the class who made an A on the first exam, and I had the highest score. So the moral of this story is, do not let anybody mock you. Well, you can't, they will mock you, but don't let it change your behaviors. If you find that coloring things helps you keep stuff straight, then by all means do that. That means you're probably a visual learner, like me. So colors and shapes help you keep things straight in your head. If you need to do that, do that. It doesn't matter what anybody thinks. It doesn't matter what anybody says. What matters is your comprehension and your final grade in the class. So remember, when I got my grade for that class, it shows an A on my transcript. It does not have a drop-down menu that says, but she had to use colored pencils to do this. None of that shows there, right? And I now review journal submissions that use multiple linear regression analysis. So the moral of the story is, make sure you keep focused on the goals of the class, which is your comprehension and earning your grade, which should reflect your comprehension. Do not feel shamed by any particular techniques you need to use to help you understand and organize the material differently. So that is our little learning tip for the day to go along with this lecture. I suggest you use colored pencils. As we go along, you'll notice that I use different colors for different components of a particular formula because that will also help you keep it straight in your mind. I suggest you adopt that as well. Next up, we'll be going through and looking at calculating other measures of set term.